Hello. Um, Welcome. And here we are in the shader hour. I'm excited to be here.
Hello.
Oh,
Welcome.
I just heard myself in the mic. 1 second. Here we go. So, today I'm going to be working on a project, a VFX project I have with BattleGoat Studios, who are my previous/current employer. We're doing some contract work, and I'm really just going to be sketching and explaining myself as I go along, thinking out loud, talking to you if you are there. And I see someone has asked a pressing question. Keegan, the answer is always 8. And Chris, you were very close, but 9 is incorrect. And now that that has been said, I don't know. I want to talk about what we see on screen for a little bit. I am using, for those who don't know, GLSL, which is my favorite shader language to write in. A lot of really fast functions, useful things. It's really easy to convert to other languages, I find, too. And yeah, let's see what we got here. I did a little mock-up here. I got some shapes rotating. Oh, those are hateful words. Somebody, where's my moderator? I gotta kick Santiago out of this chat. Let me see. How do I do this? Put user in timeout. I won't do it for real, but I can. Be warned. First warning. But yeah, I got some stuff on screen here. This is unrelated. I just thought it'd be nice to have something more than a black screen when I started off. Or I guess traditionally with shaders, we often do the UV coordinates first, which is the green, red, and yellow that some of you might be familiar with. You might not be. I don't know your personal comfortability. I'm just working here and you're watching, so let's have some fun. No, that's perfect. No! Alright. Yeah, so my plan here today, so the title you see, I'm going to be working on this effect for Galactic Ruler, which is a space game, and trying to come up with a Orbital Surveyor effect. I'm thinking to keep things really geometric and simple, almost like an icon, but we'll see kind of what happens as it develops. And who knows? I might spend an hour for nothing, but that such is the way of art. I'm gonna try to keep an eye on chat, but this back and forth is new to me, so bear with me. And yeah, I'm just gonna start, I guess. 8 is the best. It is, truly. Okay, so the first thing I wanted to do, I'm going to repurpose my circle here. Was create a planet in the center where our probe will orbit around initially. I did kind of want to work on this curve function, but I'll save that for when I need it. That'll be more fun. But yeah, circle. So, circle, I'm going to put it in the center, and we have a planet. I'm done. That was easy, right? Here, I can do funny things to it. What do I want to do with the? I wonder if I can add like 0.1 plus sine of t. Whoa. Okay, t is time. I've got time saved. It's t up here, and it's very large. It goes all over the place. So let's see. Let's get our standard coordinates for the sine function. That's obviously way too much. Ship it. That's right. It's done. Why would we do anything else? That's still way too much. So, okay, the website I'm using which is a website, by the way, is editor.thebookofshaders.com. The Book of Shaders is fantastic. If you learn anything from me, learn to go to the Book of Shaders to learn more about shaders. But they have the editor here, which is handy. The worst part about it is I will instinctively hit Control S, and it just tries to save the HTML page, which is frustrating. You can export the shader, which is nice too. I don't want my planet to pulsate, I've decided. That's probably not the smartest idea. But let's do something like this. No. Okay, I'm going to keep the planet simple for now. And the planet won't be in the final effect, because in the final effect the planet already exists and has a mesh and all these fun things. I'm going to rename my circle to planet. Might be confusing later, but that's fine. Okay. Yeah, I'm gonna delete everything else for now. That was just pleasantries. Clean up my page here, and I'm going to start working on the probe. I don't know what we're gonna do. Surveyor. Yeah, I'm going to. Okay, so just to walk you through what I'm doing here. So we have P, which represents the point on this square. I'm gonna move that down a little bit. Realized it was clipping. P is also sometimes called the UV coordinate, or ST is often used as another alternative. And I use P because it helps me think of it in terms of space, like a point in space. And also UV to me always implies 0 to 1, and directly underneath it you see I change P to be a centered based coordinate system. So it's not 0, 0 bottom left, 1, 1 top right, where 0, 0 in the middle. And that's where like creating the circle is really easy. And for that, I'm duplicating this whole space, like the coordinate system, via this function here. That's useful if I'm also kind of translating it. Where is it broken? Right, so I just translated this vector 2 by 2.5 units, both on the x and the y. So again, GLSL, really handy. You can do stuff like that. You can do that in a lot of other languages too. This website is really handy when it comes to the constants, because you have fun with it. Oh, I can't. Oh, that's strange. There you go. Minus. But yeah, but I don't want any of that right now for C in particular. But this is why I always kind of get in the habit of duplicating the space when I'm about to use it in a function. Like my circle function uses the C space for that very reason. Manipulating space is a lot of fun. Learning about matrix transformations. I spent a few weeks just deep diving into that, and that was a rabbit hole I barely touched. I'm still learning a lot. Yeah, it's a nice IDE. It's instantly updating. You see, like, if I make one error, it's just like, it's really fast. It took me a little bit to get used to, because I'm used to like saving and then hitting F5 a lot of the time working in Visual Studio, but yeah, it was, I just started using this because it was convenient, but it's kind of, I don't know, it has things I like about it. I don't know if this is going to look good, but the test function I recently found is really cool. It essentially just goes through every line. You can see it blurred everything out, and yeah, it even shows you like how fast things are. This one assignment is really high. I don't know why. Is it just because it's big? That's fine. Okay, but anyway. What was I doing? Right, we're making the surveyor now. So, okay, we have a new space. We have the surveyor's personal space. That's a good way to say it. And D is kind of our collection of data in this case, or sum of all of the things. So, and this is just a lot of memorization, a lot of trial and error. I learn a lot from other tutorials and YouTube stuff. I can talk more about resources if you want to learn. But you use something like the min function to combine multiple functions. So normally, like I can't just set D equal to the circle and then D to a different circle or a square. You have to do the minimum between them because we're using what's called signed distance fields, which are these functions which are the mathematical expressions of specific shapes, like box, circle, line. There's way more. I mostly steal these and tweak them a little bit because coming up with these formulas is just one of those things that like really smart people do, and stealing and using these formulas is something that like 98% of people do. So I'm definitely in that category for now. But yeah, so the min function, it combines the distance fields. And the distance field, if you saw during the test, let me see, where are you? Okay, get rid of this line. That's the distance field. So this is actually what it looks like, this one circle. And I can change this value so you can see. The black represents, 0 and negative numbers, and the white represents a distance. And what we're doing is, the circle is kind of the easiest one to understand, is there's a borderline here where the distance, and that's this value I'm tweaking here, kind of like the radius, is 0. And that's the borderline. That's actually where it is first set to perfect black, and that's, it's hard to tell, but it's somewhere in here. And everything inside the circle is actually negative, but we don't care because negative in RGB colors, is still just black. But outwardly it goes infinitely. And so what the function does, it says, hey, the point over here, this point, whatever point it's calculating on the GPU, how far are you out from this distance? What's your value? Are you inside? Are you negative? Are you on that line? Are you outside? And then kind of paint it accordingly. And then we just use this kind of step function down here to hard clamp that to be a hard line as opposed to the soft gradient, and that's where I'm getting that shape. What do we got? I have programmed the maps. Yeah, Keegan, I saw some of the stuff you were working on. You got some really cool visuals there. We'll have to talk more about that. But I don't really know what you mean by across many x and y values. But yeah, okay. Well, maybe you're typing, maybe you're not. I can't. The show must go on. Here we go. Equations. Oh, okay. Right. So you're viewing it in 3D, and then it is on a 2D plane, which is cool. You could do that. Yeah. Yeah. Anyway, where was I? Min. Gonna just do a circle for now. What's my space? My space is S, and then 0.05. Make it smaller. Yeah, and so that did nothing. From 0 to 100. Because that actually did. It's just in here, and we could do, so instead of min, we could also use max, which is the intersection, or where it's like positive. It's Boolean function, so it's positive where they both overlap. Which two circles in the smaller circle, it's only that circle. But if I do this now you can see it. So it's the overlap. You see the edge of the other circle there. And then there's a little trick here. I think it was that, hey, the cutout, which is max with one of them being negative. And those are kind of like the three main, what are they called? Constructive solid geometry tools that you use. So between min, max, and max with one negative, you have like all the tools you need. And let's see, okay, we got some questions. How does GLSL compare to Unity's Hlsl? Totally new to this shader game, just curious. Okay, so Unity does use... I was talking about this before, and I couldn't remember the name. So Unity shader language is not exactly Hlsl. They customized it a bit. It basically is, though, Hlsl. But what do they call it? There's another name. Oh, CG program. Yeah, I guess you can use the Hlsl program in Unity. But yeah, it's slightly different. But the main differences between GLSL and Hlsl, from what I've seen, are like functions are named differently. There are some functions that don't have overrides that I like in GLSL. For example, down here, my vector3 color, which is what I input into kind of the final output here, the final few lines, I have a constructor for vector3, and the GLSL has put in, I don't know, the extra lines of code to make it so this single float, which D is a single float value, input into a vector3 constructor, it just understands 1, 2, 3. You just want that for all three channels. But in Hlsl, I have to do this. I have to write it out, and that's not a big deal, but it matters. There are, I think Hlsl has a, I always forget which one's which, but one of them has lerp, and the other one uses step. No, step is different. Lerp and, so like the name's different, but it's the same function. They have a fraction function, which in HL, let me see here, which in GLSL is just frac. Nope, it's fract with the T, and in HLSL is the C. I'm sure there are technical differences that I don't know yet, but as far as I've done, and I've worked a lot in GLSL, and then the engine we're working with to like implement these effects uses HLSL. So I actually am often converting one to the other, and usually it's copy and paste, and okay, fill out my vectors, do that. Change, like instead of vector3, it's float3, same thing. It's just a lot of like name changing stuff. A lot of which you could probably automate, but I mean, I'm making small enough shaders that usually it doesn't, I don't think it matters. But let's see here. So where was that? Zoom in. Not negative. Whoa, that's a new one. The min negative. Aw, that's a cute planet. But yeah, so I will pinch that off. S dot y minus equals okay. Let's just call it 4. No, that's too far out. 3. Yeah, of course. Please ask me questions, because it'll fill the time out, and I like answering questions. Okay, let's see. Although it's very distracting also, so who knows? maybe it's not a good idea. Right, so our second dot, he represents our orbiting surveyor. What should I want to make it a different color. I want to start throwing colors into this. No, you know what? No, we're going to save color for later because color gets complicated. I might not get to color tonight. Black and white might be where I stick to it. But let's see here. So I want to make this guy orbit around the planet. And the easiest way for me to do that is to do matrix multiplications. And I talked about this a little bit in my last little streamy thingy. And this is just memorization. This is, I learned about this, and I realized this was one I would use a lot in my work, and I spent the time memorizing it. Okay, and now this is always the fun part, is when you're dealing with space and matrices and stuff, order of operations is crucial, so I'm trying to rotate. That's what this is doing, is trying to rotate. And this is technically rotating, so let's... Cam froze? Oh, thank you. I might do my backup cam, because I don't really trust running in background. Yeah, totally frozen. Oh wait. Backup cam it is. Okay. So it should come up in a second. This one's not as nice. I'm sad. I was using my cell phone with an app that sends the camera out because the cell phone is better than my webcam. But clearly that didn't want to cooperate. But this is why you have a backup plan. And thank you, Chris, for letting me know. That was helpful. Just like laser focus. Yeah, that was funny. Alright, what do we got here? 0, 1. What's my box function? Hey, okay, so yeah, so it was rotating, but it's a sphere, so you can't tell when a sphere is rotating. But now it's a box, and now you can tell that it's rotating. I'm going to leave it as a box for now. Maybe a little smaller, maybe still a little bit smaller. Maybe not that small, we'll see. I'm just getting fiddly. But yeah, I kind of like that it's rotating. So I'm gonna duplicate this. I can't. Keyboard shortcuts don't really exist in this, which is sad. Like Control D to duplicate my line. Yeah. Can I do negative on the matrix? No, it doesn't like that. Yeah. I really like Control D as a keyboard shortcut and Alt up down to move things around. I'll probably transition out of this for like future streams. I just like, it's just also so clean. I don't know. Anyway, so here, yeah, we got an orbiting surveyor thing. It probably shouldn't be rotating that much, so I'm gonna just get rid of this for now. I just like the way it looks. Yeah, okay, so I like that. So it's always facing down. So I had an image for this in my head that it is sort of like, well, like a space probe, like a shuttle with like spindly kind of sticks and some like radar dishes, probably spherical body. this cube right now is just like a rough approximation of the size, but this is what it is. And then what I final thoughts here is what I kind of want it to do is ping like little data waves toward the planet. It would be really cool if it like pinged the data wave, and then the data wave like reflected, and it captured the data wave, and it had this like bouncy effect. But that might require a lot more math than I will have time for tonight. But I can send the ping out. So actually, let's. I want to set that up. So signal. I like trying to find a different letter. So I have surveyor and planet already. I'm going to change planet to target. No, I can't change target. Planet, it's fine. And I guess I'll just call it ping. Commonly, Q is often the next one after P. Like if you're used to iterators, you know, you do your IJK. I've seen P and Q. I don't know if there'd be a third one. R? I haven't seen anyone really use R for space, but usually between P and Q, that's enough. Or you start getting more creative with the names. Like, I would actually call it surveyor space or surveyor. Just surveyor even would be fine. But I'm trying to keep my lines short also. Let's see. Yeah, so Q, we're just going to copy P over. And I want it to be at the same exact... Actually, okay, so here's a fun one. I want it to be at the same position as the rotator. So I could just use the same space. But I also want it to move down. So I can't some space unless I copy it here. Rotation, space out. Okay, let's try it. Let's try Q is equal to S. So let's start that out. And then Q dot Y is minus equals T. And now we do our daemon, and I'll make this a circle for now. Always good to start with a circle because it's really easy. 0.01, really small. Just shoot that. Oh no, forgot the min. So the minimum of D itself and the circle. Time. Hey, we were talking about fract earlier. Oh, look at it go. Yeah, we're gonna add that instead. Two. Okay, but it's got to disappear. It can't go through it. It's gotta be slower. So do I do divided by 2? Yeah, divided by 3. Okay, and then actually multiply this by... There you go. If it ends inside the planet, that's probably fine, right? Now I gotta speed it up. Now it's too slow. I'm reading the planet signals right now. That's what we're doing. And I was thinking like little cell phone signal type of effect there. I really think the bouncing would be cool. I could probably... Actually, now I need to try the bouncing. The bouncing might not stay because it might seem a little cheesy, but it's kind of cool to do that. I could just do it with a sine wave, really. Okay, so I'm gonna save this. That is a useful one. So we do QY plus equals let's do absolute of sine wave of time. What do we got? Are you coming back? Okay. That's not bad. You're super fast, so we gotta slow you down and make you not go nearly as far. So let's divide by 2.0 by 3. Blue. Okay, needs to be faster? And not go as far. It needs to bounce right away, so not go as far. Oh, there it is. So, what do you got for me? So that it enters on one side and then gets cached on the other? Yeah, you could figure out the timing so that it like just passes through and then catches it. That's kind of cool. Like I could see an actual space probe doing something like that, where like it just like shoots out this ray and then like goes around and catches it. I mean it's less that's less realistic, I think, because like the speed of light of signals, depending on what the signal is. I mean, this is probably like Star Trek level imaginary tech at this point, but okay, you got it. Yeah, so like bouncing radio waves off of the planet's surface right now. And I don't like sine wave, actually. It's like it should probably just be like hard, straight and go, but the sine wave eases it in and out too much. But that's fine for now. Kind of gives me the picture. I don't know. I might just do I'm gonna leave it, but this was more what I was envisioning. Like you're just sending the signals to the planet. I want it to orbit a little bit slower. Oh. Okay, so I need a new T. Float. T1 equal to T. And divided by 2. Yeah. Boom, 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 boom. Yeah. Well, that's kind of what it was doing, wasn't it? Where like it technically, like what it's actually doing is it's shooting it straight at the center, and it happens to be going back, so it's sort of faking the angling. But yeah, have you tried mixing with like cosine, and it would travel differently? Do you mean, Keegan, are you talking about inside the mat 2 here? Or just, I guess, down maybe, or no, you're talking about the ping. Yeah, I'll try it. Like, I'll throw some stuff out there. What do we have? I don't know why that... Yeah. I'm not really... Whoa! Oh, that's a bit faster. I guess at this point you're like... doing, but it looks cool. I'm okay with this. So then if we take the absolute now and divide that 5, it still has a bit of easing, and I know there's some functions I can figure out that would just make it a sharp back and forth. Yeah, I'm just gonna, again, for now, I'm just gonna stick with the non-bounce version. I think that'll be fine. Yeah, so okay, I got a few things to work on here. I can flesh out the look of the orbital probe, or I could flesh out the look of the ping. The ping will require me to do the curve function, which I kind of wanted to do anyway. So maybe I'll do that. I like the idea of that. I should probably just look this up, but I wanted to try to do it from memory, which is doing like a simple, is it a Bezier curve, I think, where you're looping from multiple points, lerping from multiple points. So let's see. Vec2 AB is equal to lerp. So yeah, lerp, it's not lerp in, it's mix, yeah, mix A and B of, I don't think I want 0.1. See. Okay, so I mean, right now this is not doing anything. I should preview this. What's the best way to do that right now? No, this is not gonna do what I want it to right now. I'll come back to this, probably. What I need to do now is disregard everything we've been working up to this point, and we're going to do float D1. D1, yes, perfect. Okay, and so I'm going to draw the ping because I want to test something out. So I have this, and let's do so vector 2. Call it. Do I have L? No, L1. We're gonna have multiple lines, I know. So P at the center, and D is equal to min of D, and line of L1. Do a radius of 0.02. And what do I want to do here? Okay. Vector 2, A1. The lines are going to get a little bit wordier. I want it on the x-axis. I'm going to do -1 and 0. That's where I would like to have a shortcut to duplicate a line, and +1, 0. Okay. And then let's do A1 and B1. What? Oh, not D1. Sorry. Oh, that is cool. There's a line. You can see it. See, I love my shader errors so much. They're much more fun than regular programming errors. Because so you can tell. So I drew this horizontal line, and first of all, I didn't step the value, which means it's fuzzy, and so it's created this really dark image, but it's very ominous. I like it. D1. But now I will step it. Cool. And yeah, I mean it's just a pure line. I'm going to multiply the space. There it is. Why 4? Let's do 4. I'll have to adjust that. Okay, so what I'm trying to get right now is I want 3 lines slightly shorter than each other, all kind of lined up. So I'm going to create another one. I'm going to create L2 equal to L1, and then L2 dot x specifically is times equals, let's call it, let's do 2, and then we're going to duplicate this line, except with the L2 space. Oh yeah, and then L2 dot y is minus equals 0.1. Where did my other line go? Why are you like this? Oh, I'm still screwing up there. Okay, yeah. No, I want it to be more, and I want it to be less. Okay, so now L3, same idea, multiplying by 1.5 again. Maybe keep that consistent. L3. Oh, I didn't define it. Make it equal to L2 dot y minus equals 0.2, so keeping things on the same scale. And one of these 2 D1 lines. Yeah, so remember every D line, D1 with the minimum is just adding to the picture. I think of minimum in this context as add, and I'm using different spaces where I'm shrinking the space each time and moving it up slightly. Oh, 3, yeah. Now, so here I want to do something fun now. So what I want to do is curve these lines to make it like a little Wi-Fi symbol, like a signal. And so I'll do that right here onto L1, and then it should propagate down. I hope not wrecking anything. Okay, L1 dot y is plus equals the absolute value of L1 dot x is Li L1. Oh, see, that's cool. I went the wrong way though. I did negative equals. Yeah, that looks cool. I love how sharp that is. I was wanting to do something a little more curved, but hold on, I can still get to a curve from here. So we're straight adding it, but we want to like quadratic it. Pow. Oh, it kind of warps it. It doesn't look as clean with the power function. Actually, I probably don't need the absolute because power covers that. And I guess I could move this down more. 7.5. That wasn't as pretty as I thought it would be. Way too much. If I move this, does it fit? It's perfect match. They do fit. But that is undesirable. What can I do? I can do, oh, maybe, let's see what happens. Oh, we're getting weird values. Or we get negative values. Oh yeah, okay, so I do need the abs. Because math is weird. Oh, what? Look at this madness. Okay, not abs. What's happening here? Right? Oh, now I've lost it completely. Does that have to be exactly 2? Huh. Math is so weird to me. This legitimately feels like magic. Like I often don't know what I'm doing. And you look at a finished shader and there's so many constants that have these like weird decimal places, and it I mean, I couldn't even apply names to a lot of the constants because they're just weird. So this is okay. I don't love it though. Minus. So the absolute thing. 5. I'm gonna stick with this for now. This is cool. I might add one more should add one more. 2. L4 dot x times equals 1.5. 4 dot y minus equals 0.5. And yeah. 4. That looks like a fishbone. Okay. Now the trick here is going to be replace our dot with the fishbone. I'm gonna look into making it curved because I really like that idea. Okay. So okay, get rid of that. D D D D D D D D. Well, okay, so yeah, here's a good look at the field right now. So this is what it looks like before the step, and you can see, I just love the way this looks. And there's my step. So move that back, and so my ping has to be equal to the S. Okay, we're going in the right direction. We are not nearly small enough. Let's do 10, 20, 30, even 40. I'll stick with 40. I'm going to do Li minus equals 0.1. Move this around. Oh, just the y component, actually. Minus equals -1. And what are we doing here? So really, it's just this line. And then comment that out. Put this in, and it is Li. Ooh. Okay, yeah, so the math here is going to be way off because I was doing to a different space. Okay, so I actually need to multiply this by 10 probably. Yeah. Right on. So it's looking pretty cool. I'd still think it would look better. Yeah, I don't like the fourth one in this angle actually. That's nice. Yeah, it'll probably look better once I figure out how to curve it better. But for now, that's a good indication of what I'm going for. I want to make these things a little bit thicker maybe. Especially when you're getting really small, you're going to start seeing the aliasing on the pixels, but yeah. I'm very happy with that. That is looking really nice. Okay, let's get rid of this. nice cleanup. Okay. That's a big one for the ping. There's a lot going on here. Different shapes. Woo! Yeah, alright, let's get rid of that. I'm trying to clean up the code a little bit here. Yeah, thanks, Chris. I think I'm probably getting pretty close to wrapping up here. The other thing I wanted to do was just kind of create a better final image for the orbital, but that'll probably have to wait. I did a quick sketch here. Maybe I'll show you the kind of get the picture here. I don't know how well it's gonna show up, but that is kind of what I was thinking. I mean, that's really rough, but just something sticky with some extra shapes, sending out these signals. Add some color. Do some fancy graphics to make it look a little nicer. Thank you. So this is no. So I could do one. I could do a pixel card, but it could take a long time if it's a really tough one. Hold on. Ooh. 1 second. Alright, I got them. Okay, yeah, so for those unfamiliar, the Pixel Spirit deck is a pack of cards that I purchased because they have... they're just gorgeous. For one, I just really wanted to own them. But they contain shaders, so you'll probably... I'm just going to grab one at random. So, I mean, you can see how this looks a lot like what we were working with tonight. Black and white, very geometric, I could make that so quick. They all have shader code on the back. You can't read that at all, but you can see there's some code there. And, okay, I could do the stone. That's the one I split the deck in half. What, should I do the stone? That'll take me... Time me. I bet you I can do that in a couple minutes. Let's see. Okay. Oh, I'm not gonna cheat. I don't look at the back of the card. I try to do it from memory, or if I really have to, I might look up a function on the internet. Okay, I'm just gonna do what I did before. Actually, oh yeah, there's another way to do this. I could just set D back to 9. Restart. Because I'm using minimum, I just set D really high because it's white. Yeah. So let's see. The stone. Okay, so again, trust me, I'm not looking at the back, but it's pretty straightforward. Let's do it. Okay. I mean, there's lots of ways to do it. It's creative. I could do 4 squares that are purposefully placed. But that'll get fiddly. I think I try to, or I could do 1 square and then duplicate it 4 times exactly, or 3 times around. Or my first instinct was to create 1 rotated big square and then just cut out an X. Which is probably what I'll do, because I can just use 3 boxes. Okay, so here's the stone. Box. Let's do vector 2. Do I have B1? Did I? Yeah, redefinition. Okay, so box 1. A little bit more verbose here. Equal to P. We'll start right at P. Okay, so D is equal to the min of D and a function called box of box 1 and I'll just hard put the values in here. That looks about the right size. Okay, that might be a little small. I'll make it bigger. I'll make it bigger. It's nice and. Oh, I've never tried this, but this is cool actually. Oh yeah, the Vector 2 tool. That's cool. I like that a lot. Stop. Okay. Do eat, and those are wild. Oh yeah, so the pixel cards are really cool, and I think like theoretically you'd start at the beginning, which if you watch my last stream, I think I do the first like 6 or 7, and I'll probably continue and do the rest on another stream. But the first one's Void, which is just black, which is cool to me because it's like it's really easy. You do 0, 0, 0. I mean, that's Void. That's super easy. And then they get more complex, like card number 2, Justice, which is this. And the names come from, I believe it's also a functional tarot card deck, which I know next to nothing about, so please don't ask me about that. But maybe teach me. If you know something about tarot cards, teach me, because I would like to learn. I'm too busy learning shaders right now, but one day I'll be able to read fortunes. I try to be respectful. I'm sorry if that was disrespectful. I don't mean to be. I don't want to hurt anyone's feelings. And I think tarot cards are really cool. That's part of the appeal to me. It was like, whoa, these are like there's the shader magic, and then there's like this other magic. I don't know anything about it, but I really like that kind of stuff. What was I doing? Oh yeah, I'm doing the stone here, so you can see it again. Boom. I'm not looking. I swear. I assume you trust me anyway, but you know. Let's go. So I have my box, so I have to rotate it. Fortune shader, yeah. See, it's really crazy, and like, you've only seen like a few of the cards so far, but the shaders, that like these abstract representations of these tarot card concepts are cool, and tarot cards often have like really cool art associated with them that's supposed to help like evoke the meanings behind the cards, and these, I think, like, they're very minimal and abstract, but sometimes in some way I think still evoke a certain kind of magic just from the image, which is really awesome. Okay, so who remembers how to rotate things? There's gonna be a quiz. Oh yeah, okay, so N is equal to pi, which is a constant I just manually set up, I think 4. I'm trying to rotate 45 degrees. I might need to do that by 8, but I'll just see what I get first. The other thing about like shader programming, especially in a tool like this, is it's fast. Like, you get weird errors and you get them fast, and then you keep moving on. It's very, I'll see, perfect. We're halfway there. We're almost done. I've technically gone over an hour, so I think I will. I should come up with some kind of punishment. Like, if I can't complete the stream in under an hour, like what I intended to do, then I don't know. Someone come up with something. Yeah. Okay. So that was easy. Box 2. should set that as a variable then, shouldn't I? Yeah, so setting the matrix as a variable, and now I can reuse it more easily. And d equals min of d, and box function of box 2 space with a vector 2 of 0.1, 0.1, which is not going to be right. You're not gonna see it, but it's there. And oh yeah, instead of min, I want to do max negative. Hey, so that's a cutout. That's cool, but that's not what we want, right? We want it to be. Oh no! All right, I can like get it really skinny. It's so easy. I love this tool. That looks to be about the right thickness proportionally. So now this whole thing I'm going to copy. Blame that Chris guy for going over by asking for a card challenge. It's definitely Chris's fault. Okay, and then I just need to rotate it differently. I wonder if there's some easier way to do this. Oh yeah, box 3.x times equals -1. What do you think? Did I do it? Yeah, I think I did it. Now I'll allow myself to look at the back of the cards, because then, like, sometimes, so the author's name is Patricio, so Patricio does it sometimes, like, very differently, and that's always fun to, like, oh, why did you do this? Or like, the numbers are different. I mean, like, sizes are always going to be a little bit different, and but it's still fun. It's fun to look at. I mean, clap. Yes, clap. Thank you. Yeah, he just rotates the whole space, and then makes a rectangle, and then uses a stroke instead, which is, he created a different function to create a stroke, like a line. But I mean, that's also just easy to use boxes like I was doing. These cards are really cool. Really cool. I'm very happy to get them. I was waiting a long time because they were out of stock for forever. Definitely check them out. I think they're in stock now. I had notifications, and it was like, oh, they're in stock again, and I just was like, buy. Because I knew I wanted them for a long time. But that's Spirit deck. Oh, I think this is one of them in there, which is cool. I'll have to take a look at that one. But that's it. I think I'm gonna call it for now. Oh, okay, good. See, this one, so I can comment all this stuff on. Let's look at what we did today. We created a rotating cube, or square technically, with like a little signal thing, and I like this. This is good. It's really challenging and fun, and pushes the boundaries of my mathematical knowledge, and I love it. I love this stuff. So that is all for me tonight. I am very happy to have some people hanging out, asking questions. This was a good time. I want to create a consistent schedule, and if I figure out what that's going to be, I will let y'all know. But for now, I'll just try to give you as much notice as possible, and at least once a week, I'm going to try to do something like this. It won't always be work related, and in the near future, it might be game design related more so than just shaders. So stay tuned for that stuff. But for now, thank you again. And I don't have a sign off. So just like bye, I guess.